we know about galvanic cells by these fan dandy folks. So here is a diagram of your galvanic cells, a device where chemical electrons convert to electrical electrons. These symbols must be positive in order for the galvanic cell to work. Alright, so with the anode, this is where all the electrons from one substance go to another, and this is where the oxidation occurs. At the cathode, all the electrons will end up in this cell, and all the reduction will occur there. So, this is what you do with writing half reactions. You assign oxidation numbers, you decide who is being oxidized and reduced, you write down the half reactions, and you balance the atoms and the charges of each equation. With the E cell, what you want to do is the cathode plus the anode. With line notation, it's basically galvanic cells without drawing the diagram. You have your electrode, which is typically a metal, because metal has a sea of electrons and can take all that. And you got your aqueous anode, and this is the separation, the double lines. The cathode is the aqueous of the chemical that's gaining the electrons, and here's their metal that's gaining the electrons. Now here is a typical galvanic cell example. Here's your original equation. Right here is your balanced half reactions for both oxidation and reduction. Reduction and oxidation. And finally, you have your balanced final equation, which is typically your net ionic. Now right here is the process of finding out the voltage of the E cell. Now for voltage, it's going to be 3.6 for reduction, while oxidation, it's going to be negative 1.33. You add them together, and you get a small charge of 0.03 voltage. And it will be spontaneous because it's positive. Now here is an example of the galvanic cell diagram. Typically, you either have platinum as your metal, as it is an inert metal, or you can use a metal that's being used in the equation. Here's all your cool little aqueous solutions for cathode and anode here, and here's the line notation for that diagram. Now, this is our key that we use. Blue is original equation, orange is balanced half reactions, purple is the balanced final equation, green is galvanic, pink's line notation, and red is E cell. The end.